Hello, our names are Andrea and Kim, and this is our ME220 sensor fusion project, the SPY monitor. This application involves using the IR rangefinder and magnetic field sensors in order to detect if someone is approaching. This would allow a spy to get warning if a guard is headed toward them, with the benefit of being able to screen out non-important intruders, say, if a cat crossed the line of the sensor. It simply requires the PocketLab to be placed near a doorway at about hip height, and it is ready to start sensing.
Users will open an Android or iOS app on their smartphone or tablet. The app communicates over Wi-Fi or Bluetooth with the PocketLab. When the user wants to begin monitoring, they place the sensor and press a trigger button on the app. This both sets the initial settings of the sensor, magnetic and IR baselines, and begins monitoring for the changes associated with the passing guard. While the coast is clear, the app shows a wait icon. When a guard is approaching, the app shows alerts to the user silently via the app. The app stays in an alert state until the user clears a notification from their screen. If multiple guards pass through the beam, the information is displayed. A single magnetometer reading or single IR rangefinder reading might provide a false positive. With both modalities, we achieve a greater level of certainty in our sensor reading. With only the IR reading, a stray cat or other object blocking the beam will trip the sensor. The addition of the magnetometer reading reduces false positives.
Here's an example of the data stream that would be seen by the PocketLab in a few different situations. In the first panel, there is a drop in the rangefinder distance indicating that something has walked in front of it, but there's no corresponding change in the magnetometer reading, so this is likely the cat walking by. In panel 2, there's a fluctuation in the magnetometer, but nothing changes on the rangefinder. For example, a computer near the PocketLab has turned on, but there's no guard approaching. But in the third panel, we now see both the rangefinder dropping and a fluctuation in the magnetic field. This indicates that someone has crossed by carrying perhaps a radio, and that the spy needs to be notified that the guard is approaching. You can also see on the X data that the magnetometer raises up and then lowers before returning to baseline. This sort of data can be used to determine which direction the guard is traveling.
We can gather even more information, such as the direction of the passing object using the 3-axis magnetometer signals in tandem. Via the Hall effect, a positive signal on the PocketLab, on an axis orthogonal to the face of the PocketLab, indicates movement in one direction, and a negative signal indicates movement in the other direction. This is useful for a spy since they may want information on whether the guard is approaching or moving further away from their current location. The length of time that the IR beam is disrupted gives us information on how large the object passing is. A large guard may pose a greater threat compared to a small one. Comparing the time difference between the magnetometer and IR readings can provide information on how quickly the person is moving, walking versus running.